Today we're going to talk about convex mirrors. So convex, a mirror with a surface that curves outward, like the one we see right here. And this type of mirror, the practical purposes are, it provides very large areas of reflection. So you're going to see these used in cars and their side view mirrors, in stores. This large mirror, which you see in front of you, this is from the old media center in the old school. And I had a couple of them, and when they tore down the old school, they gave me all the mirrors, and I guess students used to steal books once, and they would use this, so if you're in one corner, you can see what's going on. So you still see things like this in convenience stores. I mean, now we see a lot more video cameras, but you'll still occasionally see mirrors in like convenience stores and stuff like that to make sure no one's stealing anything. So first of all, this type of mirror is diverging. So diverging means that when we look at the ray diagram, we see the rays of light spread out, because the word diverge means to spread out, and we had learned yesterday that converge means to come together. So images formed by diverging mirrors are always, so this is important, because when you're doing problems or you're doing your ray diagrams, you can check it to see that they're always going to be virtual, erect, and smaller. So if you're doing a problem or you're doing a ray diagram and you see that your image is not virtual, it's not erect right side up, and it's not smaller, then you made a mistake. Okay, so that's a good thing to remember. So again, they're used in security and stuff like that. And this just shows what we mean by diverging. Now we know mathematically working these types of problems are simple. The difference between these and what we did yesterday is going to be our sign convention. Because remember, in physics, the most important thing so that everything works out perfectly is our sign convention. And as long as we have a frame of reference from where we're measuring from and we're consistent with our sign convention, everything will work out perfectly. So again, we're going to be using our same equation, 1 over f is equal to 1 over di plus 1 over do. Remember, we don't want to just memorize the equation, and even though in this example I jumped from here to here, today when we do a sample problem, we're going to go through all our intermediate algebra steps in order to rearrange the equation to solve for the unknown in terms of the known. Oh, this is in general. Whenever we're doing problems, whether they're convex or concave, and we're doing anything with a mirror, there's 4 questions that I can ask you. So you have to think about this when we have our test next week with our FRQs. So the first question is going to be, where is the image? So when I ask you where is the image is going to be di, the distance of the image. That's what where is the image means. Is the image real or virtual? So as far as our frame of reference, whether it's positive or negative, that's going to tell us whether or not the image is real or virtual. Is the image upright or inverted? So then when we're looking at whether it's this way, our sign convention for HI, so if the height of the image is positive or negative, that's going to tell us if it's upright or inverted mathematically, and when we do our ray diagram, we'll see if it's on top of the principal axis, it's upright, and if it's below the principal axis, it's inverted. And then when it says what is the height of the image, you know whether it's going to be smaller or larger. So we can do it mathematically when we solve for HI, or when we're doing our ray diagram, we'll see in our when it's to scale. Okay. And then spherical aberration occurs because the rays of light of a spherical mirror along its outer edge are not reflected through the focal point. So here, this shows spherical aberration where when the rays of light come in and they're parallel and equidistant to one another, how they don't come together at one point, and this is what happens. So we'll talk more about this next class, because today we're going to just talk about convex mirrors. Now, before we do the problems, I want to show you one thing. Or we'll do it when we do the problems.